The objective of this problem is to determine the shape of the distribution, but we must first do several things to get to that point. As you can see, we're just given some raw data about violent crimes, and these are crimes per 100,000 in population by region of a certain country. And we have these parts that we have to complete. So because this is raw data and it's not really probably easy data to work with by hand or to type into a calculator, I'm going to choose to use StatCrunch. There's a couple of ways I can access StatCrunch here. I could go directly to StatCrunch like this. I'm not going to do that one though. I do want to select Tech Help, however, because the Tech Help is directly related to the type of technology and the source or resources I would use within that technology for this problem. Again, I just mentioned how this would be probably difficult to write into a TI calculator, so that's why I'm going to use StatCrunch. If I click this pop-out window, it will leave that as its own separate window. You can see here. So I'm just going to minimize that for right now and come back to it and using the StatCrunch in particular, those instructions. Now, to copy this in StatCrunch, I'm going to click this small icon beside the table, and I'm going to open in StatCrunch. Let me log in. Okay, so I just logged back in. Let me try this one more time. Open in StatCrunch. Okay, and now I see those values here in my StatCrunch window. But I'm going to be going back and forth, so I may move some screens around as I go here since I've got several things going on. The first question asks that if 13 classes are to be formed, choose an appropriate lower class limit for the first class and a class width. Luckily, I'm not choosing with too many options. I have some choices given to me here. And a couple of these I'm going to end up throwing out because of the values that are in my table. For instance, I definitely cannot choose 500 as the lower class limit. I have several values here that are below 500, so that would not be appropriate. I could choose 0 technically, but I'm so far from 0 in all of these values. So I'm going to move on and see if there's a better choice. 100, again, I could choose. 200 I cannot choose, and the reason why is because of this particular value in my table. And there may be another one, but that one caught my eye. So if I had to choose a better lower class width, or I'm sorry, a lower class limit, I would choose 100. Now, next, as far as class width goes, if 100 is going to be the lowest, how wide should these classes be in order to form 13 classes? Keeping in mind, I think my largest value up here is about 1300. Well, if I go by 100s, counting by 100s, I know I can get there within about 13 bins or classes. Those other options, by the way, that one's way too large. So that would be like saying from 100 to 599. And then from 600 to, what would that be? 1099. So I'd only need like 2 or 3 classes to cover all of the data. If that one's too large, this one's also too large. The 50 is too small. So if I were counting by 50s, I would go from 1 to 149.9. And if I keep going like that, I'd have way too many widths. Again, they're telling us 13, so that's why 100 is the best answer choice. Okay, so for next, constructing the frequency distribution, this is where I want to turn to my information from the Tech Help. Okay, so this is what we're going to do inside StatCrunch. We're going to construct this frequency, and if we need to, I can't remember if this question asked or not, a relative frequency table for continuous data. So if necessary, enter the raw data into the spreadsheet. We don't have to do that because that has already been done for us when we copied it. It does say that we need to name the variable or name the column variable. That column is already named for us, var1, short for variable 1. You could rename it here if you like, but you don't have to. So next, I'm going to select data, and I'm going to highlight bin, and I'm going to click that one. So let's follow through what happens after that. Let me minimize this just a little bit so I can see both of these on my screen. Just a little bit better here. Okay, so after that, let's see, click the variable you want to summarize. So I'm going to select the column var1. Click the use fixed width bins button because we already determined this. We want to start at 100 and we want bin widths of 100. That was in that first part. So we did those things. It says leave the include left endpoint radio button selected. Okay, that one's already selected for us. And then click compute. So let me come over here. You can see now a little bit further. I have this compute button. So this is a new column, bin of variable added to the data. Okay. Now I'm going to select stat, highlight tables, and then frequency. So let me select that one. Click the bin of the variable, and under type, select frequency. It says and relative frequency. I'm just going to do frequency to begin with because I'm not sure if I need relative just yet. If I need to, I can come back to it. Right now, you saw both of those were selected, so I just unselected by clicking on relative. Now only frequency is selected, and click compute. And here is our frequency table results for our information, for that raw data. So let me minimize this one. And here is what's going to go inside my answers. Now notice they do a bin from 100 to 200, but what they're saying there is they're not including that right endpoint 200 in my math lab. They're going from 100 to 199.9. The 200 gets included into the next bin. All right, so that's two different ways that we can represent class widths there, but just to be consistent, you know, obviously we're going to use what my math lab has. That's what we're doing here, but I just wanted you to understand what those values mean. So let's take a moment and put that information in. Notice that there's a big skip here, so that means I'm going to have some bins or some classes that have 0 frequency. So again, all in all, when I type in those values and put in the zeros, the bins that were not represented from StatCrunch, this is what I should have. This is my frequency distribution. It's literally a count of all the raw data that falls within each class. I see now that it is asking me to construct a relative frequency distribution. So I'm going to go back through those steps inside my math lab. So let me come back over here. Not every step though, because I already have the bin step taken care of. So if I go to stat, tables, and frequency, remember earlier it did have both of these highlighted. Sorry, I forgot. I need to at least tell which column to look at. We're looking at the column bin of variable. This time I'm going to only highlight relative frequency. And then I'm going to compute. And you can see those values are here. One nice thing about using StatCrunch is you can use your shortcut keys to copy and paste. So now it is, I have to pay attention to this. It's asking me to round to 3 decimal places. But I can highlight those 3 decimal places and either Control C or Command C, depending on what type of computer you're using. I can come over here and Control V or Command V and paste that value. And so it's a little bit less typing. Notice that this one, I would have to round that 3 up. So I'm going to have to make a manual adjustment and round the 3 up to 4 and so forth and so on. So I'm going to go ahead and fill in those values now. Now remember, you had several bins that were not represented in this relative frequency table. So I do have to account for that by filling in some zeros for relative frequencies. Just be aware of that because it doesn't represent those zeros here in StatCrunch. I have to manually do that. So for the next question, it says construct a frequency histogram of the data. And this might be a little bit simpler since we're now dealing with not quite as much data as it was in its raw form, but I do want to show you how to do this same thing in StatCrunch. So we're constructing a frequency histogram. So let me go back to my StatCrunch instructions. And for a histogram, it says, if necessary, enter the raw data, which we shouldn't have to do that. But we're going to select graph and highlight histogram. We'll click on the variable we want to summarize, choose the type of histogram, frequency or relative frequency, and all that good stuff. So let me start showing that over here. All right, so we're going to select graph and histogram. And you can see I have some different options here. I do want to say what my data is, okay, and that's the variable I want to summarize. Next, choose the type of histogram, and in this case, at first, we're looking at frequency, so I'm going to leave that alone as frequency. The other option there was relative frequency. You have the option of choosing a lower class limit for the first class by saying that the bin starts at 100 and it has a width of 100. Those are things that we decided in the very first part of this problem. And then it says we can enter labels for the X and Y axis, enter a title for the graph. All those, I mean, that would be really lovely, but we're going to end up just matching this graph. So I think we have everything that we need in order to match the graph. So let's try compute. And it's right here. So here is our relative, I'm sorry, not relative. This one was our frequency histogram. And so when I'm looking at my answer choices, this seems to most closely match choice A. We'll do the same thing for relative frequency. Okay, so I'm going to start from scratch here. I'll go to graph, and then I'll go to histogram. I select my variable. This time I am using relative frequency. I start my bins at 100, and they have a width of 100. I don't have to do anything else with that, so I'm going to just go over here and click compute. And here is our relative frequency graph. Now notice how that looks exactly like our frequency graph that we selected earlier. The only difference is what you see along the y-axis, that scale along the y-axis. These are counts or frequencies. These are proportions or relative frequencies. So I'm going to find that graph here. And then the last problem, this is really the objective of the problem, is to describe its shape. And if I look back at the shape of this distribution here, I'm going to say that this one is right skewed or skewed right because it has this long tail with that very kind of outlier piece of data, I guess we could say, over here to the right. So wherever the tail of the data is, that's skewed right. Just for like a comparison, this one would also be skewed right. This one would be skewed left if I had to describe something else. But our data look like this in a histogram, so we're going to say that that distribution is skewed right because the right tail is longer than the left tail.